Okay, hi guys. So in this lecture, we'll be continuing on seeing graphs of radial part function of a wave function, or radial part of wave function rather. So we'll be seeing the graph of p orbitals. So starting with 2p here. So let's get started with 2p. So the graph for RR versus R for 2p would be starting from a 0 value and would be something like this with no radial nodes. Then for 3p it would be something like this, the graph between RR and R with one radial node. Okay, for 4p it would be something like, again RR versus R, it would be positive, negative and positive, two radial nodes here. Okay, one radial node here. Then for, let us look for 3D, 4F and 5G, it would be something like RR versus R, again starting from non-zero value and having a positive sign here. Then for again 4D, 5F and 6G, the graph would be something like RR versus R would be with one radial node. Positive and negative here, so this is one radial node. So now let's look at very important formulas which you all should remember. So number of radial nodes when you are calculating for any orbital should be determined by n minus l minus 1. Okay, and nodal planes or angular nodes should be calculated with the value of L, and total nodes should be calculated with summation of all the two, so it would be n minus 1. So please remember these formulas, or formulae rather. Okay, you can cross check with any of the orbital here. So let's say we are calculating for 3D. So for 3D, radial nodes would be n is 3, L is 2 and minus 1 would be 0. For 4F it would be again n is 4, L is 3 and minus 1 would be again 0. Let's calculate it for 2p. N is 2, L is 1, so n minus L minus 1 is again 0, so number of radial nodes are 0. For 3p, n is 3, L is 1, so 3 minus 1 would be 1, so it would be one radial node present here. Okay, similarly for 4p you can apply the same formula and cross check. N is 4, p is 1, n is 4, L is 1, so n minus L minus 1 would be 2, so two radial nodes are present here. Okay, so let's continue. So let's actually draw the graphs of r square r for all the orbitals. So let's say we have 1s orbital. So I hope you remember the graph of 1s orbital, that it starts from non-zero value, and let's calculate the number of radial nodes with the formula of n minus L minus 1. N is 1, L is 0, minus 1 would be 0. From non-zero value it is starting, so graph would be something like this. This is a graph of r square r versus r for 1s. Okay, so next let's see the graph of r square r versus r for 2s. So 2s is again the s subshell, so it would be again starting from non-zero value, and the number of radial nodes would be n minus, or rather 2 minus 0 minus 1 would be 1. So it would be something like this, positive. Oh, this is the graph of r. So what would be the graph of r square? The graph of r square would be something like this, positive and positive both. So now let's look at the graph of r square r versus r for 3s orbital. So for 3s it would be something like, again it would be starting from a non-zero value. I'm not writing it again and again. So, and the number of radial nodes here would be 3 minus 0 minus 1, which would be 2. So starting from non-zero value, 2 radial nodes would be this and this. Okay, next let us have a look at 4s. So for 4s we would be having r square r versus r again. So for 4s again it would be starting from non-zero value, and the number of radial nodes would be 3, hence 1 2 3 radial nodes are present here. Okay, then let's look at 2p. So for 2p it would be starting from a 0 value. Okay, so, and how many number of radial nodes will be there? 2 minus 1 minus 1, which is 0. So this would be the answer here. Okay, so now let's have a look at the value of r square r versus r for 3p. So for 3p we would be having number of radial nodes as 3 minus 1 minus 1, which is 1, and starting from a 0 value, so it would be something like this. Okay, next have a look at the graph for 4p. So for 4p we would be having the graph as this, r square r versus r. For 4p number of radial nodes would be 2, and starting from a 0 value, hence it would be something like this. Next let's have a look at 5p. The graph of 5p would be again r square r versus r. For 5p would be having 4 radial nodes. So graph would be 1 2 3 and 4. 1 2 4 radial nodes would be there. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing radial probability density function, or RPDF. Okay, and we'll be seeing some derivation on the same. So till then, good luck and goodbye.